Hey everybody, it's Dr. Lusheen. This is week 3. We're going to be covering chapter 2. This is for Safety 201, Personal Public Safety. On the screen here, I've got a new module in Canvas called the News Event Assignment Guidance. I don't know why I called it that, but so I've got a grading rubric here to kind of guide you, the team members working together and what I expect. You can go to week 2 and look at my PowerPoint if you want to get an idea. I provided 2 different types of PowerPoint backgrounds for you. They're whitewater backgrounds. And then this is where you're going to upload your documents that you want to use during class or share during class. So every Monday, we'll have 2 or 3 new people presenting what they found to kind of provide some contextualization, some news event type materials, video type, entertainment type of materials, just to kind of prep everybody on Mondays for the chapter lecture on Wednesday. So for week 3, this is the recorded lecture, just like if we're together. It's going to be shorter, obviously. Afterward, I would like you to then take the quiz. It's 10 questions. It's multiple choice. Based on what I learned from the first quiz for chapter 1 is that I need to keep the questions closer to the definitions and concepts in the chapter. I tried to get cute. I ended up dropping 2 of the questions from the quiz. So the updated or adjusted scores are posted on Canvas now. And so we'll see how this goes. You have 25 minutes to complete 10 multiple choice questions. Work on your own, please. I could have installed or required the use of something called Respondus, which requires you to go through this whole litany of things to show that you're taking the quiz yourself. I'd like to avoid that if I could. I feel like it's an extra layer of difficulty. You can use your notes. Once you start the quiz, you need to finish it. You can't come back and do it. So get your notes together, get your materials together, sit down, take it. It should only take you 5 minutes, 10 tops, but I'm giving you 25 minutes for anybody who is allowed to get more. It'll be 1 question per page. The responses are mixed up or whatever, so it's not like if you tried to take it next to somebody, they would have the exact same layout. It's that way. So please follow that. I do appreciate it. And again, you have till Sunday night at midnight to get that in. So, at some point this week, listen to this lecture, look at the book, and then sit for it. It's not meant to be difficult. This should be a lot easier than the first one. Okay, with that said, I did not like using somebody else's PowerPoint. It was too long. So this week I'm going to try something different, and that is I'm going to go directly from the book as I review it. So this particular chapter is dedicated to statistics. I was supposed to be the one who wrote this chapter, but due to the literature search I was doing, it ended up I wrote I think it's chapter 14 on misinformation. So I'm going to speak both to what you see in this chapter and some of my feelings towards it. Hopefully that'll help. The vignette itself, Riley is exposed to several different episodes during a day in which the term statistics or research are brought up. And at the end, he's just questioning, what is this all about? So it's a good beginning. This chapter is only like 11 pages, but half of them are other things. So let's get into it. So what the author said here is that statistics is the science of making inferences about the world based on numerical data collected regarding a specific phenomenon. Because they have 2 references here, I'll accept that. Statistics are used in many different ways in research. Well, they're used for the one particular single reason, but different types of statistical methods are applied based on multiple factors of the particular study. And the reason I'm speaking about this topic the way I am is that with my graduate degrees, I went through, I don't know how many methods courses, how many stats courses. If you recall what I said in week one, I basically have minors in psychology and sociology, in addition to my degrees being in industrial engineering and systems design. So, and I received a classical graduate education versus some of the more hybrid or completely online versions that are available today. So yeah, maybe I'm a little bit of a research and statistics snob, and that may come out, and I apologize for that. But it's just I've been there, done that, still doing that. So we'll go with this definition for statistics. I think the science of making inferences is more along the lines of traditional research methodology. That's what I would. That's when I read this. That's what I was thinking. But for this class, it's making inferences, and it really sometimes statistics all they do is represent a particular status at a particular time, or a status under a particular condition, or a status within a particular population subset. And I would go off on weird tangents. Actually, right now I'm teaching a research methods class to graduate students, and so that's where when I read this chapter compared to what those students have to read, it's different. It's quite a bit different because they actually have to write a research proposal for the course, and yeah, so it's much more involved. What I do like here is that many people say doing research. So when I go online, social media sites, somebody posts something and somebody disagrees, and what they say is do your research. What they really mean by that is do a basic internet search. That's all they're saying, because that's not what research is. Research is something that's much more specific, that you've narrowed down a question or a set of hypotheses that then you can collect data, and that could be observational, that may be survey or opinion, it could be actual measures of something using instruments, and then you analyze the two. It's like you think of like an experimental research is like lab research. So you're basically controlling all the things in the world that affect, they call them confounding factors, that would affect, whether a treatment causes a change in something. And then they just do it multiple times in multiple ways, in different variances, in order to study how something affects something else. That's inferential. To infer this causes that. That's a very specific type of research, laboratory research. But for someone like me or anybody in the safety field, we tend to do things more in the real world. Therefore, it's difficult to control the confounding factors. I'm going way off, and I'm really sorry, but just understand that research is much more involved. There's much more planning and design that goes into it. But when somebody goes, do your research, what they're saying is just search the question, type it into Google, and you'll find some answers. Which brings us to the next point, and that is reliable sources. Yes, I basically, I do all my work within reliable sources. And reliable sources are those which tend to be, go through some sort of refereeing phase. And it says right here, scholarly peer-reviewed journals. And so I've been on different editorial review boards is a bad term. I've been part of the peer review process in which I receive a manuscript that was written within my area of expertise. I'm a subject matter expert, and I reviewed it and I provided my feedback. I also know that when I read certain things, I can see what they're referencing or citing as their sources, and verify what those, am I familiar with those sources? Is the technique that they employed the correct one? The data they collected, did they make sure that they adhered to human subjects protection? Did they properly handle and go through and synthesize the data to make sure it wasn't wrought with any errors or faults, things like that. And then then there's the sort of the construct and the face validity. Doesn't even make sense. But anyway, reliable sources are those which are controlled or refereed by experts or textbooks written by credentialed individuals. Those are usually people with terminal degrees, PhDs or doctorates, maybe Masters of Science with experience. And government websites tend to be also mostly reliable, especially since the information is typically published through either peer review or credentialed individuals. And then it's offered through government websites. So those are reliable sources. But you have to be careful because there are publications from like professional associations that are not particularly refereed. They may be edited or discussed briefly, but they are more likely to contain biased results or biased interpretations and things like that. But sometimes they have good information too. So if something's published in a magazine or a publication which has a lot of advertisements in it, probably not as reliable. But if it's by experts who challenge themselves and it's built on previous work, then it tends to be more reliable. So that's kind of that. In general, what do you need to know? That it's typically peer-reviewed, scholarly, or done by people who have degrees and are credentialed, or government websites. That's what reliable sources tend to be. Others you just have to take with a grain of salt. For example, on the screen here, this is Opinion X, so this is not a reliable source. But in reading about mixed methods, which is using not just one singular research methodology, but in this site, what they're doing is they're justifying the use of both qualitative and quantitative data, which I strongly believe in. And I kind of read it through, and they have some good points here. So like here, they got behavioral, attitudinal, qualitative, quantitative. So this is the training I had received on how to judiciously employ these different methodologies based on what you're trying to do. So yeah, but is this a scholarly publication? By no means. And I don't know who these people are. It looks like they're trying to sell something. But it's just, they've got some interesting graphics here too. Exploratory versus explanatory. These are concepts I teach in my methods course. Here, you're trying to figure things out, then you measure them. Here, you already have the measure, but then you're looking for additional, more qualitative in order to get insights. And that's really what it does. It gives you insights. Anyway, getting way off topic with these things. Okay, sorry about that. I'll try to keep it more specific to it now. In safety, we find a lot of our information through textbooks and government websites, and through certain journals. But the journals, quote unquote, offered through some of our professional organizations, even American Society of Safety Professionals, it's an editorial review board. So it's not peer reviewed, but it receives a level of scrutiny before being published. But if you look in the Professional Safety Journal itself, there's all kinds of advertisements. There is editorial opinion, letter to the editor, things like that. But then there are other journals that, like the Journal for Safety Research, Safety Science, that's just in the safety field itself. The Synergist. There's a entire team of volunteer peer reviewers who are typically professors, or those who work in industry, and then they're called upon to review, 2, 3, a dozen papers a month or a year. And it goes through several layers of review at that point. Okay, that's what I'll say about that. So as far as the research steps, it really comes down to a question that you're trying to answer. Now, you may think that's similar to what I said before about, you search a question. But no, you basically have to do a comprehensive literature review in the scholarly journals to define everything that is currently known, leading all the way up to the point of what question you're trying to answer. And it usually is very specific, because this is what we know, and you're kind of reaching a point of what we don't know, which is really, I wish that was in this chapter, because that's how I teach my research methods course. Is research is the pursuit of what I don't know. Does that make sense? So right here, you're doing a question on a particular population, that is the subjects involved. A sample population, or they just call a sample, is a smaller portion of that larger population. And if you do your research study properly, you should be able to extrapolate the results to the greater population. unless there's a caveat or limitation in the way you ran your study, in which you then confine it to the characteristics of the sample in which you tested. Data collection, there are some terms I do want you to know. Validity corresponds to how closely data collected is to the real-world situation it was supposed to represent. I had brought up the term construct and face validity before. There are different sub-headings, sub-considerations of validity, but the big one is how close it is to the real world. Next is accuracy. And there are some pictures on the next page that kind of show accuracy versus precision. Accuracy is how closely a data point matches the true value it is attempting to measure. So accuracy kind of sounds like the data's version of validity. Precision, on the other hand, is how consistent, which is closer to the reliability. The precision of measurement, by measuring the same data point and again, you'd see the same result. So in the dartboard example, accuracy is that it's at the target you're aiming at. Precision is a closer collective of the shots. You know, that you're hitting the same thing. Accuracy is you're going at the right thing, which would be the center of the target. So for research, though, we use validity and reliability. Reliability is how reproducible the data or results are given a different researcher. So is it represent what it's supposed to using the same measurement tools? Or is there something else influencing the measures, which is making the data collected different? I don't really like that, but I do like this. So this is accurate and precise. This is accurate. This is precise. This is neither. Is that correct? I didn't even look at that before. I just know that when I was taught these things, they all use the dartboard. Though this dartboard is egg-shaped, I don't think the picture transferred real well. So accuracy, again, is towards the target. Precision is repeatable. This is both. This is neither. So it's kind of cool. I think this chapter really talks about two classifications of statistics. One is descriptive statistics, and that's really just what it represents. That can be a count, that can be a percent, that can be a rate. You know, it's just sort of classifications, or what we would call, descriptive representation. It doesn't answer a question per se, though. Pre and post treatment, or pre and post, delivery of something that should change it, you could compare the two, and the difference between them could become your result. But then you're not really doing just descriptives. You're probably analyzing the variance. So an ANOVA, a corollary study, regression. I dare say structural equation modeling. I don't like to use stuff like that, though. So first, there is the mean. Mean is average. That's commonly referred to as average. It's calculated by adding together all the data values and dividing by the total number. So that's the mean. The median, on the other hand, is the exact middle. And what they really mean by that, if you know about percentages, is the 50th percentiles. It's the 50th percentile. So whatever that measure is, 50% of the number of subjects is on one side and 50% is on the other side. 50th percentile, the median. Why is that? Why is it good to use one or the other? Because if you have a skewed distribution, the mean and the median will be different. If something is skewed to the right, the 50th percentile, the median will be to the left of it. If something's skewed the other way, it'll be there too. So the average or the mean is influenced by outliers, whereas the median is not. And comparing the two gives you a basic indication of how skewed or kurtosis your distribution may be, and that dictates which statistical methodologies you can use. The mode is the most frequent value. And then down here it talks about normal distribution, which is the bell-shaped curve. In a perfect normal distribution, the center point is the mean, the median, and the mode. Okay? When all those line up, you tend to have a normal distribution, which is to say a center point and almost mirrored like decreased to tails. And as you go away from the median, the more those dots become fewer and less representative of the population statistic. Okay. The standard deviation is a measure of how spread out the data is relative to the mean. And that is, again, that's assuming normality. And where do they talk about that in here? Normality? Normal distribution. Okay, yeah. So all of parametric statistical methods are predicated on the assumption of normality, which is to say mode, median, and mean are all in the middle, and there's a standard deviation which shows off to the bell curve. I don't know if this is helping you or not. And all the equations are based on that assumption. Now, when you don't meet that assumption, when something is very skewed, and actually I'm writing a paper right now that injury data, when it's plotted by count and severity, violates the normal distribution or the assumption of normality, and the curve is actually asymptotic, which is to say that therefore reporting descriptive statistics for injury data severity and frequency are invalid. They're not representative of what you assume they are. You don't have to get into that in this class. That's my burden to carry, if you will. But maybe by the end of the semester, I'll share with you some of the work, in case you guys need something to help you fall asleep. So the standard deviation is just the measure of how things go out. The basic idea is once you get beyond 3 standard deviations, you're really only then representing, I believe, 0.25% of the populations are out on those edges. The standard deviation can represent a pretty narrow representation of what the population is. 1 standard deviation out, I believe, is like 66%, 2 is more. And it's too bad that the author didn't provide those, because then you can visually see how these descriptive statistics and normal distribution all relate to each other. So that's what I want you to know. Yeah. Visuals, how do you present results? So here what we have is a pie chart, because it kind of looks like a pie. And what it does is when you consider all the measures, the totality of the measures, this is a way to both represent a representative percent or count of the total, but also the size of each piece provides a visual representation, a comparison, if you will, of how they compare to each other and how they compare to the total. So that's a pie chart, very basic, and it's just descriptive. There's really no analysis here. It's just boom, that's what your measure is represented. Pie chart. Pizza chart. A frequency distribution, on the other hand, does a side-by-side comparison, and this can be both in chart form or table form. And here you can see obviously that B has the highest number of students or the highest count, whereas D has 0. And so that's the difference. So you're not seeing as a percent or representation of totality, but of individual comparisons, which I believe may provide a little bit more insight if you're trying to determine something. This is a histogram. This is a frequency distribution chart, okay, or table. That's the difference between the two. It's a side-by-side comparison without really representing the totality. And these tend to be, you're visually looking at it, but it's more of a numerical thing. It provides a little bit more insight. A frequency polygon, on the other hand, shows here, and this is exam percentages versus number of students. So it's leaning towards more of it's a frequency polygon, but it's almost like a distribution in many ways. So that's how it is. So this is a frequency polygon. It's like a distribution, and that's exactly what the author calls it, and that's what I would call it too. Moving on, rates, on the other hand, I like rates better, and here's why. Because you have a count of something, but if you count something, but the subjects in which you're sampling always tend to have a higher representation of it, then the count will always give you this false interpretation that it is a majority, that it accounts for more. But in actuality, the consideration of the sample or the collection itself dictated it. I had talked about this when I was discussing with you the causes of death in the U.S., fatalities. That heart disease and cancer are number 1 and number 2 overall, but that's because the higher age ranges, predominantly that's what their cause of death is. And to project those 1 and 2 to all age ranges would be incorrect, because under the age of 45, it's unintentional injury. that causes death. Similar thing here, that if you look at it from a rate perspective, it's either per time or per person or per hour of exposure or per type of exposure. So one quantity of a specific unit or measure divided by the quantity of a different unit of measure. Exactly. So mortality rate, number of deaths due to a specific cause divided by the total population. So that's what we looked at in class. But then if you break it down by age group, it changes because you have different number of people in each age group, and you have a different fatality rate or mortality rate within each age group. Therefore, looking at the descriptive statistics overall is a little bit misrepresentative if you're going to be studying or coming up with solutions of different age groups. The age itself becomes a factor, confounding factor. Injury incident rate. I'm glad that the author used this because the proper term is injury or illness incidence rate. Incidence rate is actually a public health term. It's the number of new disease. It's the proliferation of disease through a population over a period of time. But here it's the number of injuries that are incurred. It's actually the OSHA recordable injury and illnesses per 100 full-time employees, which is FTE. And she talks about it down here. The author talks about full-time equivalency of 100 workers working 40 hours per week, 50 hours per year. 40 times 50 is... Wait. 40 times 50 is 2,000 hours, times 100 workers, 200,000. And that's the consistent. You do not have to memorize the equation. I just want you to know that the injury incidence rate is a calculation of the number of recordable incidents in a company per 100 full-time employees per year. It's an annual rate. Though some people calculate it in smaller amounts, that's not proper. You shouldn't do it that way, because then you should modify the constant here. So it's full-time equivalency. So 2 part-time workers working 20 hours a week for the full 50, that's you would call that 2 workers, but it's actually the equivalency of 1. That's all that means, and you don't have to know that for any quiz or anything. I just want you to know that it is the number of recordable incidents per 100 employees per year. That's what I want you to know. Inferential statistics are a little bit more sophisticated, in which in that point what you're doing is you are indeed collecting data and running a statistical methodology to determine how variance compares. That's really what most of the parametric statistics do. Variance is basically the square root, or is it the squared? I think it's the square root of the standard deviation. And if the standard deviation is incorrect because you have a non-normal data set, then obviously you can't use that statistical methodology reliably. Yeah, I use that right. Or it's not valid. It's kind of both, right? So there are independent or predictor, thank you, variables. Independent would be, characteristics of your subjects. They would put them into different types of groups. Age, for example, or education level, height, weight, speed, things like that. And then what you're doing is you're applying a treatment to find out how that affects those individuals based on those independent variables. And so the result measure is the dependent variable. It's dependent on the treatment, considering the independent. Here are some scatter plots, and what we're basically looking at is we're doing corollary studies here. That does one vary at the same rate or increments as the other? So here, there really is none. Box A, example of scatter plot with no relationship. I agree with that. You'd have a corollary, like a Pearson correlation of 0. If there's no correlation there. Here, it's a positive correlation. They move positively with each other. Is that what they said? Box B is an example of a scatter plot with a positive slope. And because the data points are close to the best fit line, it's probably got a higher R-square value, which is another corollary statistic. Here is a negative correlation, so it'd be a negative positive. And I believe, like in my classes, I teach that anything above like a 0.7, but sometimes I like to aim for a 0.8, which means 70-80% of the changes between the two are similar, other than some randomness in there. And these are, that could be like a zero point 0.6 to 0.7. That looks more like a 0.8 to 0.9 to me. And that's just off the top of my head. Now, I really wish this chapter, if I had written this chapter, we would have talked about the different forms of error. The author kind of took the easy route and just stuck to p-value. P-value is a measure of probability. The calculations are not random. So the closer a p-value is to 1, the less like error or variance is in the result. And so, like I said, a p-value, well, it's R-square value really, but a p-value that is lower, I'm sorry, I just screwed that up. Don't listen to what I said. P-value is from 0 to 1, where 0 means the outcome never occurs by chance. A value of 1 means the outcome always occurs by chance. The values in between. So separate the two. So correlation is different than p-value. So you want a lower p-value. And so a p-value of 0.05 is 1 out of 20, 5%, which is a 1 out of 20 chance, I believe. Yeah, a 0.01 p-value is 1% or 1 out of 100 chance of it being by chance. And when you think of like the normal curve, that like the tails or whatever, I think 3 standard deviations in both directions, you're at a 0.25 and a 0.025 and a 0.025, which would be a 0.05 two-tailed analysis if you were to be run like a t-test or something like that. Again, you don't need to know that, but I do need you to know that the p-value is a value between 0 to 1, and it basically measures the outcome, the chance of the outcome being random. Yeah, the outcome occurred by chance. Again, a 1 is bad, 0 is good. That's what it means. So write that down. Again, it's a 0 to 1. The closer it is to 0, the more reliable the result is, that it's significant. If it's closer to 1, then it's less reliable. It's more likely that by chance, you might find something significant. Okay. Yeah, that's good enough. I think I screwed that one into the ground. I hope you guys do well with that one. Data interpretation is a whole nother issue. It's very short here because, as it should, it takes years of training to get all this stuff down. I mean, I was in grad school for 6.5 years, and I kept learning afterwards too. So trust those that are that are degreed and credentialed when they tell you certain things, because they've gone through a lot of training and they've been tested quite a bit. It's not like they ever make their decisions on their own. Bring in other people. So, okay, so 30 minutes, that's not too bad. Be careful when you read statistics, look for reliable sources, know the difference between, descriptives and non-descriptives. Some of the things you need to know, do know a definition for statistics, know the difference between search and research. Why is this important in research? I don't think we had that one. Why would a researcher use a sample instead of a population? Well, you have to, but that's not part of your quiz. Difference between descriptive and inferential, know that. Know when a visual should be used, know the p-value, know the basic definitions of mean, median, mode, know what a p-value is. This is off the top of my head. But have access to your notes in your book when you take the quiz. But that's really it. I think from now on, this is the way I think I'm going to review things, because after I have the quiz written, I do focus on certain aspects. Of course, this one, I'm a nerd. I could have gone off. I'm going to shut up now. This has been almost 35 minutes, but that's a pretty good time to end things. Again, please complete the quiz. For the students who are going to be doing the Monday lecture next week, please use the rubric to kind of guide you. These slides are meant to be, to help you put something together, then upload your materials here. And that would be links to websites. That would be links to YouTube videos and also your PowerPoint, so I can have it ready for you. Thanks, everybody. Have a good week.